Alright, hello everybody and welcome to my presentation. My name is Pouyan and I'm doing my PhD studies in information systems at the University of Canterbury. My research topic is about using distributed ledger technologies and specifically blockchain technology in agri-food supply chain for improving trust and value among stakeholders. In this presentation, I'm going to talk about the background of my research, the methodology, the goals, and the prospective conclusions that I expect to have in this research. Thank you very much. Right, so as I mentioned, my topic is about the role of distributed ledger technologies throughout the agricultural value chain. Okay, so here is our research approach to the future. First, we have a deep dive into the macro factors that are shaping the future of how people will consume food in the future through collecting information from experts, stakeholders, and consumers. Then we will make hypotheses and develop initial research findings into key provocations that will impact the future of food consumption. Then we will share and facilitate discussion around future provocations with industry experts and food supply chain stakeholders. And finally, we will take action to create an industry playbook that summarizes findings and outlines the strategic actions and roadmap for the next years. All right, so here is our definition from value chain. Generally, a value chain can be defined as a set of activities that a firm operating in a specific industry performs to deliver a valuable product like goods or services to the market. Value is a central concept in general management, and several authors suggest that the delivery of value to the end customer is the reason for a firm's existence. Consequently, value creation does not occur in isolation, but rather within a value chain framework where companies can collaborate most efficiently as members of the chain. In food value chain, due to the rapid development of world's economy over the recent years, people's living standards improved a lot. But unfortunately, research showed that consumers' trust in food production industries has been deeply broken due to the recent misconduct and scandals that we have had in this industry. Nowadays, consumers have become more vigilant about the moral and social consequences of products that they consume. So they're more inclined to know if the products that they purchase have passed through a sustainable food value chain. So transparency, or in other words, value chain transparency has been proposed as a new value which can create competitive advantage for companies. The concept of supply chain transparency was almost unknown 15 years ago. But nowadays, Customers, governments, and companies want to receive more transparent information about the system and the sources that produce and deliver the foods to them. On the other hand, the reputational cost of failing to meet this demand can be high for companies. So, as an innovative action, the Google company is running a program that uses an app to collect data from ankle bracelets worn by chickens. So it can provide customers with some information like how many steps have been taken by each individual chicken, or the time that it has been slaughtered, and even the time of death. Okay, so now we want to go over the potentials of New Zealand food value chain and the value that it can provide to its consumers. The first one is the country brand. The literature actually recognizes that country of origin can provide a competitive advantage that is not easily copied. According to the survey from Future Brand website, New Zealand brand has been recognized as 11th in the world. So it has got strong reputation, which is below Canada, Luxembourg, and Austria, but above United States, the Netherlands, and Australia. Country of origin has been actually in several studies used by consumers as a cue for desired attributes like quality and food safety. The other potential of New Zealand food industry is cultural authenticity. It's a credit attribute that has been identified as offering value to final consumers, and generally it gives meaning to the food by telling an interesting story that connects the food to specific people or specific place. In case of New Zealand, it might not have a strong internationally recognized cuisine culture, but its culture does generate associations between food products and environmental cleanliness. Its pastoral culture actually emphasizes the raising of animals in green, semi-wide open spaces to produce grass-fed free-range beef, lamb, or dairy products. Such products are the expression of an underlying authentic pastoral farming culture, which is in sheer contrast to the global feedlot farming culture, where animal protein is raised within heavily mechanized and industrialized environments. So here we have proposed distributed ledger technologies for food value chain, and we have tried to draw a comparison with the traditional system. Traditional systems have information systems that are generally centralized and might have many problems. The main weakness is that this kind of centralized systems are mainly exclusive, symmetric, and non-transparent information systems. This could lead to trust concerns such as fraud, corruption, tampering, and forging information. On the other hand, we have distributed systems that there is no central authority that controls the transactions between members, and all the data is stored on the network and accessible by authorized members. And here we have drawn a comparison between these two that shows distributed systems are more trustworthy, but they are not as mature as traditional systems, but they have very good potential to be used in future. So we have decided to best detect the most important features of distributed ledger technologies that can be used for improving value in agricultural value chain, and we have come up with 5 main features of this technology. We have called these features as theoretic, which accounts for traceability, transparency, immutability, compliance, and transparency. Using traceability, distributed ledgers can record all the transactions history over the time and straightforwardly reconstruct the records and detect of a product, for example. Transparency means that the transaction data is generally visible. So the architecture of distributed technologies creates transparency for its users. It's also temporal evidence. So according to Oxford Dictionary definition of the word temper, it means to meddle or interfere, to misuse, alter, corrupt, or distort information. So temper resident or temper evident approaches are applied in this technology for being protected against tampering. This technology is also immutable, so the data is extremely computationally expensive to alter once it's placed on a network. And it can also use smart contracts for implementing compliance. So using smart contracts, distributed technologies like blockchain can automatically run certain activities according to the predefined regulations. So now the question comes up that what are the main requirements and priorities of DLT-based system users for creating more value-added products in agri-food value chain? We know that agri-food value chain consists of various sections from farm to processing and packaging, and then to distribution, and then to retailers, and finally to the consumers. And all these actors have their own requirements and priorities when they want to use distributed systems. So to maximize the value in agri-food value chain, we need to best detect these priorities and requirements of different stakeholders and try best to match them with the features of distributed technologies. So we have come up with several research questions. First of all, we want to know that what are the main requirements and priorities of distributed system users associated with theoretic features for improving agri-food value chain. And we want to know that how do the priorities of distributed system users differ between the stages of agri-food value chain. And next, we want to know that how do the priorities of application users affect value between different stages of a distributed ledger technology-enabled agri-food supply chain. And finally, we want to know that how does the use of DLT in conjunction with the IoT would contribute to New Zealand agri-food value chain improvement. The general approach in this research is design science in information systems. So design science is a sequence of expert activities that produces an innovative product or artifact. Therefore, a design science research artifact includes any design object with an embedded solution to an understood research problem. Artifacts created in DSR are however complete information systems that have been implemented practically or used in practice. Instead, artifacts are innovations that define the ideas, practices, technical capabilities, and products through which the analysis, design, implementation, and use of information systems can be effectively and efficiently accomplished. The evaluation of the artifact then provides feedback, information, and a better understanding of the problem in order to improve both the quality of the product and the design process. This build and evaluate loop is typically iterated a number of times before the final design artifact is generated. So the core artifact of this research for collecting data is Q methodology. We have proposed Q methodology in design science research because in design science research, actually 3 categories constitute the main source of artifact, which are people, processes, and products. In this research, we have focused on people because integrating the subjectivity of the user experience with the system design process takes a vital role within IS studies. The main principle of Q methodology is enabling researchers to discover and learn about the assortment of human subjectivity in order to identify, understand, and categorize individual perceptions and opinions, and then cluster stakeholders based on their perceptions. So we decided to use this methodology to explore the assortments of users' subjectivity about requirements in design of a distributed system that tries to enhance the value of products in food value chain. In this research, considering Q methodology as a research artifact, we are going to explore the participants' subjective perceptions and opinions about the requirements and priorities for improving value in various stages of agricultural value chain. We have collected a list of subjective statements called the Q set which reflect the stakeholders' requirements in different stages of agri-food value chain. Our statements have been collected from books, previous surveys, research reports, and through interviews with industry and academic experts. It was done to best display the diversification of viewpoints on the requirements and priorities in agri-food supply chain that can be best fulfilled by theoretic features of distributed information systems. So we have developed two Q sets consist of 50 equivalent statements each that are supposed to be sorted by our prospective respondents. The Q statements are developed to be sorted in scenarios in different stages of agricultural value chain. So here we have got a sample of our Q sets. As you can see, we have got two sets of equivalent Q sets, which will be given randomly to our participants, and they are asked to sort the statements based on their priorities for the requirements in distributed ledger technologies in agri-food value chain. For implementing the Q-Store, we will hold a symposium at the University of Canterbury with the collaboration of AgResearch company addressing the DLT integration with IoT for value improvement in agricultural value chain. Our Q-sorting participants include stakeholders from all stages of food supply chain plus final consumers. We are planning to implement Q-sorting based on the scenarios in each stage of agri-food supply chain, including production, processing and packaging, warehousing and distribution, and retailing. Separately, we will have Q-sorting for final consumers of agri-food products. So we will have two separate groups of participants. One is stakeholders of food value chain, and the other group would be final consumers of food products. Before starting Q-sorting, in the symposium, we will give a presentation about our research to make the participants more familiar with the research background. So this will improve the quality of Q-sorting by participants. We will request the Q-sorters to imagine themselves in scenarios as a user of blockchain-based information system in various stages of agri-food supply chain, and then prioritize the statements based on their requirements from most agreeable to most disagreeable regarding the extent to which they believe fulfilling these requirements would contribute to the improvement of shared value for the value chain stakeholders and consumers. The participants will be guided throughout the Q-sort, and we will be instructed to think throughout each statement regarding their conception from present topic, and then put it into one of three approximately equal sized piles from most agree or most important to least agree or least important. Then the participants are instructed to use the pies and put cards individually in the grid's empty areas. Considering that there is only one empty area for each statement in the sorting grid. The grid is designed in the shape of a quasi-normal distribution curve, as you can see. So the cards are placed at the sides of the grid are those statements that people feel strongly about, either disagree or agree. Towards the center of the grid, statements are sorted that participants feel more ambivalent about. And finally, the results that we expect to have from Q-sorting are explained over here. So sorting the statements from most agreeable to most disagreeable by potential users would help us to explore their subjectivity about the system requirements and priorities for value improvement and value sharing in different stages of agri-food supply chain. As a result, at the first phase of our research, we expect to make contributions to the result of subjectivity-driven information systems studies. And the results of this section will be incorporated for developing our conceptual framework for value enhancement in the next phases of this research. Thank you very much for your time and your interest for knowing more about our research. Thank you very much.